Tēnā koutou, tēnā koutou, tēnā koutou katoa. My name's Kate and wanted to talk to you today about a trans-Tasman investigation into Lamprey Reddening syndrome. As I mentioned earlier, I come from the Cawthron Institute in New Zealand. It was a philanthropically established organisation just over 100 years ago, and we were established through Sir Thomas Cawthron, who bequeathed a significant amount of his estate to establish an independent organisation and museum in his own name, with a vision that science would contribute to the growth of a young New Zealand. So an amazing visionary, and what he has left as part of his legacy is now over 250 scientists working in New Zealand. We're based in the top of the south in Nelson, but we also have laboratories in Auckland, and we have three main sites in Nelson itself. Really dynamic organisation, not only consulting, but we work on research contracts with industry and also contestable funding, similar to what you would call an ARC here in Australia. So government funding as well. And mostly working in freshwater and marine aquatic systems. So here are some quick pictures of some of our sites. Halifax Street, shown at top right, that's our main site in the centre of town in Nelson. We have an aquaculture park where we work quite closely with the aquaculture industry, and we have tenants that lease land from us at that site. And most important is a biocontainment facility that I championed when I first moved to Cawthron, which was a $4 million investment by the organisation. So it was a lot of hard work to get it across the line. And we work predominantly on pests and diseases and toxicology in this containment facility. So at the moment, I lead a 5-year program. We're about halfway through. This is through our MBIE government funding. And I'll talk a little bit more about the program, but it came about largely because of the rapid rate of emerging diseases in freshwater and marine environments in New Zealand. And the graph here just shows the number of aquatic investigations per year that were led through the Ministry for Primary Industries in New Zealand. And so this is the number of investigations, not the number of reports that they received. But you can see we're now nudging into one investigation per week. And it's just not feasible for the government to follow up on this many investigations. Their remit is primarily to identify and any notifiable disease. And after notifiable disease is discounted, then the case essentially is parked. So there's not a lot of research funding looking into emergence and of endemic or other diseases that might occur. So this is a photo shown of our team as part of the Emerging Aquatic Diseases program that was taken in June this year, and just showing some of our partners that we're working with. And we've got Charusha, who's speaking next, from Otago, who's part of this team, and more recently working quite closely with inland fisheries in Tasmania. We're working on Lamprey Reddening syndrome, which is quite a complex disease that was first noticed in lamprey or kanakana in 2011. And we're using these main principles to establish evidence of disease, being appreciating that disease is quite a complex interaction of the environment, the host and the pathogen, using Bradford Hill criteria, which provides you evidence that points towards infectious disease as being primary cause. And where we can, working back in the biocontainment facility in the laboratory to use Cox postulates to identify cause. But it's not always easy. So Lamprey Reddening syndrome, as I mentioned, has been around in New Zealand since around 2011, where there was a mass mortality in Southland. And lamprey, or kanakana as they're called by Māori, are a really important customary fishery in New Zealand. They are threatened, so they aren't taken widely, but they're considered what we call a tonga species, so a treasured species to Māori people. So the loss or the mortality events that have occurred have caused quite considerable grief within some communities in New Zealand. And there were some, I guess you could call some politics, and I guess some trust that was lost associated with these original outbreaks. So in investigating or reopening up this case again, we really wanted to work really closely with Māori communities to understand what has happened in the past so we can progress and work together towards a better future for Māori people, but also for lamprey themselves. So this is the Mataura Falls. This is the Mataura Falls. This is in Southland. It's in the Māori Council that we're working with in their area. And this is a photo taken of the falls prior to construction of a meatworks facility on the left-hand side and a paper mill. It was historically a place of significance for cultural collection of the species, and was dynamited to make way for this construction. So you can see this small part of the falls here is what is left existing today. And really interesting is the same species of lamprey occurs in Tasmania, Geotria australis. It also occurs throughout southern Australia. And this was the oldest picture I could get of the River Derwent that I could find online. But you can see we've had similar changes to the waterways here in Tasmania, and this is the Meadowbank hydro system. So lamprey migrate from marine waters where they're parasitic on hosts, and they migrate up rivers to spawn. So just a really brief snapshot, because I'm trying to fit a whole lot of information to 10 minutes, is what we know, or what we knew before our program. And I just wanted to highlight that in New Zealand, what we knew, or what we thought we knew, was that the syndrome was considered to be of non-infectious origin after the ministry investigation. There was no consistent bacteriology growth. But then more recently, some researchers at Otago discovered a novel member of the coronavirus associated with diseased organisms, although that was inconclusive because of lack of samples. In Australia, from an outbreak in 1979, the syndrome was attributed to a similar syndrome, I should say, hemorrhagic skin disease, was attributed to bacteria with Eromonas and Pseudomonas. But there have been no studies on viral agents. And this table is quite long, but I've shortened it for today. So in the first year of the program, we worked really closely with the Department of Conservation, the Ministry for Primary Industries, Hokonui Runanga, which are the Māori Council that work in this area, and a whole lot of other stakeholders who I won't mention, but we had quite a number of people to really work on some of the social science aspects of this problem, and what had happened in the past in returns of response to this particular mortality event and other mortality events that occurred after the fact. And that was 2 days that we spent in this wānanga discussing what had happened in the past and how we could work together to a better future, and just getting all of those really important parties engaged as part of that process. The next year, we went into the field working with Hokonui, and it was really great exchange of knowledge for our team. Well, we're all working together as one team, but for individuals working together to understand more about the traditional knowledge, the importance of kanakana to Māori, and for us to share our knowledge on science and sampling and methodologies, and enabling that sampling to be done within Māori communities themselves. And there's Teresa in this picture here, who was on this first field trip. So there's just some pictures. Of course, we don't have the cutting edge facilities there, so we've got to work with what we can and sampling the kana. And that's just a picture of my family. Thought I'd throw that in there. You can find lamprey when you go walking in Tasmania. This is Northwest River near Allen's Rivulet. So this is 5 minutes from my house. I work in New Zealand, but I live in Tasmania. It's complicated, but I love it. Okay, so we worked with inland fisheries as part of our disease investigation here in Tasmania, where the population is considered to be healthy and we haven't seen signs of this disease before. Jonah Yick, who is our contact at inland fisheries, has spent time with Indigenous Aboriginal communities to understand the relevance of kana to Indigenous Australians, but sadly, or to the best of our knowledge, the importance of kana to Aboriginals appears to have been lost, or there is some confusion around whether kana form part of the diet or whether it was eels, just through, I guess, lack of knowledge sharing or storytelling, as we just heard earlier. So what happens in Tasmania is that inland fisheries work at the Meadowbank Hydro. They capture the lamprey up through this fish trap that you can sort of see at the side here. The lamprey are captured and they're released upstream to enable their migration and their reproduction. So here's just some pictures from the disease investigation that we did. Amazingly, the day before I went for sampling, they had a major run during the night. So the trap was full of kana and lamprey. And there's some of the bacteriology plates that I did as part of that first work. Interestingly, we saw the first evidence that Lamprey Reddening syndrome does occur in Tasmania. So we're seeing some of these skin anomalies, and you can see this hemorrhage. This is how we've killed the kana, so you can ignore the notochord cut, but you can see the hemorrhage here around the branchiopores, which is typical of this disease. So what have we found? We have found several putative pathogens are associated with Lamprey Reddening syndrome. Some of them that may be familiar to you and are well-known pathogens of fish include Pseudomonas, Eromonas and Flavobacterium. And we have some novel viruses that have been detected as well. So I know Jane's standing up already. Well, if you want to know more, please come and talk to me. But what we know we're dealing with now is a really multifactorial syndrome involving really complex interactions, host pathogens, environment, and anthropogenic stresses are happening. So what are we doing now? We're continuing to build our trans-Tasman relationships, working with Jonah at Inland Fisheries and had him over in New Zealand. We're shortlisting the most likely agents associated with this disease and trying to demonstrate cause as best we can. We're supporting captive breeding initiatives with Hokonui Rananga through how can we improve husbandry and how can we treat for this disease as we try to repopulate. And we're working on artificial intelligence as a means to not only monitor numbers of returning kana, but what proportion of those animals are unwell. And then a quick advertisement is that I'm hiring at the moment. So if you're interested in joining our team in aquatic animal health, please have a look on the Cawthron website, where we're looking for a senior scientist to work on this and other very interesting cases. Kia ora, thank you.